Hey there, I'm going to show you how to export this kind of squash and stretch animation into Unreal. So normally when you export this to Unreal, the scale is not squashing in the right direction. So it actually converts to a local squash and stretch. So we're going to want to control the direction that that is squashing, and we're going to use a shader to do it with a world position offset attribute. Okay, so first thing we're going to do is we're going to get rid of this squash, um, but we're actually going to keep the increased horizontal scale. Um, but we want to store that value somewhere. So the way I have this set up is with a 3-joint chain, where the top joint is translating and scaling. The second joint is just a continuous rotation, and right now the third joint isn't doing anything, but we're going to store our scale information there. Um, so first thing I'm going to do is find the scale Y, which is the one that is squashing down, and I'm going to copy all of those keys onto our scale ref joint. So just select them all, Control C, and I'll have to set a key so that I can paste it, and then just Control V to paste all those keys in there. And while I'm at it, I'll just store all of the scale information for the other axes as well. Control V, and then for Z, Control C, Control V, and for the top joint, I want to get rid of that squash, so I'll just delete those keys. Uh, Set a key, and I'm just gonna paste, copy and paste the scale information from one of the other axes so it's scaling in a uniform way. Okay, so all those are the same. And now when it hits the ground, it's just getting bigger, and we're going to use the shader to create the squash. Alright, so that looks good to go. Gotta select all the joints and the mesh here. File, export selection. Alright, I call this ball squash animo 1. Make sure that we're baking animation and we're getting our skin weights. Okay, so that's done. Export. And just to be clear, I just want to show that the skin weights are only on one of these joints. So all of it is skinned to the rotation joint, as opposed to the top joint or the one that's just for reference. Okay, and now I want to create the base pose for this. So first I'll save, and I'm just going to delete all of the keys on these and make sure this is in a base pose. So scale of 1 for everything, and everything else should be 0. Scale of 1, everything else is 0. So that's a good base pose. Selecting all the joints in the mesh so that I can export that. Export selection, just call it ball 01. Don't bake any animation, just make sure that we're getting our skin weights. Export. Alright, so now we're ready to hop over to Unreal. Okay. So I just have an empty folder called ball. I'm going to go ahead and import our base pose first. Let's import ball. It's going to create a new skeleton, so that's right. And just go ahead and import. That'll bring in our mesh as well as our material. I'm just going to go ahead and rename this material. Call it M ball squash. And while I'm at it, I'm going to go ahead and bring in that animation we created. Okay, I don't need to import the mesh again, so I'll just import the animation. That's good. And just so we can take a look at it in its initial state, I'll just create a new level sequence and bring our ball into the environment, zero it out. I'm just going to hit G on my keyboard to hide all the extra stuff that's in there. Okay, so can bring it from the outliner into our sequence and put our squash anim on there. Okay, so we can see that it is scaling up when it hits the ground, and we don't have any squash going on yet. So let's jump into the material and get that started. All right. So as I open up the material, it doesn't have anything special in there yet, just the image connected to base color. So everything we're doing here is going to connect into world position offset attribute. So this solution actually came from the help of the Unreal Engine developers community. So if you have any Unreal questions, always throw it to them because they're some very helpful people on there. So first thing we're going to do is we're going to want to find the center position of our mesh, whatever has this material selected, and put in some vector math for squashing the top and bottom. So we're going to want world position. So coordinates, world position, and object position. I'm going to want to subtract starting with absolute world position, subtracting object position, then create a dot product. And it's going to plug into A. Okay, and we're going to want to do this twice for the top and bottom. Okay, and create a vector 3 for our color, and for our default color we'll just use blue, so up and down, it's the z-axis, and convert this to a parameter so we can control it from outside of this material, and just call this squash direction. Oops. Oh, no comment. Okay. Okay, squash direction, and we're going to want another parameter. Just hold S and click to create a scalar parameter and call this squash scale to control the amount. And so our default squash scale is going to be 1. Okay, and this vector we want to normalize. Okay, and so this is going to plug in to B on our dot product. Alright, so this one can hold M and click to create a multiply. So this is going to multiply our top one by our squash scale, and subtract again. So we're subtracting, starting with this result and subtracting our second dot product. Let's move all this over. Create another multiply and multiply this result by our direction again. Okay. All right, that all looks good, and so we can go ahead and plug that into our world position offset. Cool. Go ahead and save, which will also apply. And first thing we want to do is test that this is working. So we'll actually just create a material instance of this and can rename that MI ball squash for material instance, and update our skeletal mesh to use that material instance. So you can drag it onto this material slot and rename this slot, just call it ball, so it's easier to pick out. Okay, save that skeletal mesh, and we can open up our material instance and start manipulating this squash scale. Okay, so we can see that with our squash direction of Z, we're able to squash and stretch it in that direction. But we want it to follow our animation based on that scale attribute that we set up on the ref joint. So don't need to mess with that further for now. But we're just going to create a blueprint that's going to control all those attributes. So create new blueprint class actor. I'm going to call this BP ball. Okay. And add the component skeletal mesh. And we can select the skeletal mesh that we want, and that's just going to be ball 1. Okay. Compile. And the first thing we're going to update in here is going to be our construction script, which is what initially runs when the blueprint is created, and going to create dynamic material instance from our skeletal mesh. And plug that in to run. And we're going to want to set our element index. So get material index. And we previously named the slot for that material ball. So if you had multiple materials on the same object, you could call out which one you're pointing to. Plug that into element index. And we're going to want to store this created material instance as a variable, promote to variable, and call it mi ball squash. And from here, set scalar parameter value. And the value that we want to set is going to be the value from our ball squash material. So it's going to be our squash scale. So squash underscore scale. And we can set our default value to 1. And now our second one, which is second attribute, which is going to be the vector parameter for squash direction is so set vector parameter value, and that's going to be from our same material, so target's going to be mi ball squash, and that parameter name is going to be squash direction. Okay. And that's as much as we need to do in the construction script. So this is what it will initially run, but we're also going to want to update our value and direction of our squash over time. So we're going to do that in the event graph through the event tick. So we're going to set that material parameter again. So we can actually just copy this because it's already pointing to the attribute we want. Make sure the target is that same material again. And we're going to plug in this value by referencing our skeletal mesh. So we're going to get socket transform and break transform, break vector, and you'll remember that we were using the Y scale of our joint. Okay, and that should update our squash scale correctly. And then we also want to update our vector parameter. So again, we can copy that over from the construction script and run it again. And we're going to want to control the value to update the direction. So that's also going to start with our skeletal mesh and get socket transform. Oh, I realize I skipped a step. So for setting the value, we want to make sure this is pointing to the correct socket. So if we look at our skeletal mesh, we can look at the skeleton tree, and that's going to be scale_ref joint, because that's where we put all our scale values. Scale_ref joint. So now it should be grabbing the correct scale value from there and using the Y scale to drive that value. And similar deal for the direction, except we're going to want to use the top joint, this translate scale joint. And we can actually just copy selected bone name from here, which makes it easier to paste. Okay, so now we got that joint selected there, and we just need to break this again. So break transform, and this time we're going to use our rotation to get a vector direction, and through trial and error I've found out that the correct vector direction to use is get right vector. And that's just based on how your rig is set up in Maya. You might need to get a different direction depending on how you built it. But then you can just plug that vector into the value. So it'll convert it from a vector into a linear color. Okay, so that should be good to go. And then the last thing I want to do is I want this to also be set initially. So I want it to be set up in the construction script also. So just have this reference to the the direction also plugged into the initial parameter value for the squash direction. Okay, compile and save that, and then I believe we can jump back into our sequence. We're not going to use this ball anymore, so I'm going to delete that. Instead, we're going to use the blueprint ball. So we'll set that at 0 position and bring it into our sequence. Put the same animation on it. So nothing's going to happen yet because we currently don't have event tick running. So if we make sure that our play mode is set to simulate, then we can press play, and then we can press play in our sequence. And now you can see that it's squashing in the right direction. So the important thing that we did by setting the squash direction to the top joint is that now if we decide this is going to be bouncing on a hill or something, oh, gotta stop simulate. Like let's say we have it bouncing on a 40-degree hill. We can rotate our blueprint as well, and now when we press play, so it's not just squashing according to the world's up and down, it's squashing according to how the parent joint is set up. So let's get all 400 frames out of this. Yeah, so now you can place it wherever you want, and the animation should be maintained because it's squashing according to the direction of that translation joint. So this is just a very simple example. You could figure out much more complicated ways to use this. For example, if you have a backpack on a character that you want to squash up and down as they're running, you could put this kind of a material on it, and then it would squash according to whichever joint you set as the direction. For example, you want the spine to control the direction that the backpack is squashing and stretching. So I'd be interested to see what other um, ways you guys can figure out to use this. So let me know that, and let me know if you liked the video and if you'd like to see more stuff like this in the future. Thanks a bunch for watching.